Again, welcome to the statistics. It's ungrouped data. So again, we are going to teach us how to calculate the mean, median, and mode of grouped data. So we start our first problem. The table below shows the weights in kilograms of members in a sport club. Calculate the mean, median, and mode of the distribution. So to calculate the mean, we have our usual formula: summation of fx over summation of f. Here we need to reorganize this table in a vertical form. This table is given in a horizontal form. We have it in a vertical form. So we have the table. Create another table. This is the class interval representing the masses, and we are going to have 40 to 49, 50 to 59 as it is given in the original table. Now we have our frequency to be 6, 4, 12, 14, 7, and 3. Now from this formula, there's no room for x in this table, so we are going to generate another column for x, and that x represents the mid value of the class intervals. So we have x, which is the mid value of the class interval. That's going to give us, how do we get the mid value? Is to find the average of the upper limits and the lower limit of each class interval. So we have 40 plus 49 giving us 89. 89 divided by 2 gives 44.5, and 50 plus 59 divided by 2 gives 54.5. 60 plus 69 divided by 2 gives 64.5. 70 plus 79 divided by 2 gives 74.5. 80 plus 89 divided by 2 gives 84.5, and finally 90 plus 99 divided by 2 gives 94.5. So we now have the column for x. So we can now find our fx. That's fx means frequency times x. So, and we said the x represents the mid value of the class interval. So now we have the column fx. 6 times 44.5, we have 267. 8 times 54.5 gives 436. 64.5 times 12 gives 774. 74.5 times 14 gives 1043. 7 times 84.5 gives 591.5, and finally 3 times 94.5 gives 283.5. So we can now go ahead to add the frequencies. If you sum up the frequencies, we have 50. So we have 50 there. If you sum up the frequencies, we have 50. Very simple. 14 and 6. 14 and 6 gives 20. 8 and 12 gives 20. 7 and 3 gives 10. So 20, 20, 10 will give you 50. We now add up the column for fx. That one shall be from our calculator, giving us 3,395. So we now substitute into the formula 3,395 divided by 50. So dividing it by 50, we have from our calculator, we have 67.9 as the mean of this distribution from the grouped data. So we go for the median. So for the median, the formula for group data is given. So this LM means the lower class boundary of the median class. This is the summation of the frequencies divided by 2. This is cumulative frequency of the class before the median class. the cumulative frequencies of all the class before the median class, and this is the frequency of the median class. Here the data is arranged in ascending order, so we are going to take every parameter in this formula, solve them out, and that is the lower class boundary of the median class. First, we have to identify the median class. Since there are 50 members in the club, so the 25th and 26th members will be in the middle, since the data has been arranged in ascending order. So we add and see where 25 and 26 will be accommodated within the frequency. So we have 6 plus 8 gives 14. 14 plus 12 gives 26. So the 25th and the 26th members are here in this frequency 12. So our median class is going to be 60 to what? 69. That's going to give us the median class. So to get the lower class boundary of the median class, we look at the lower limit here and the upper limit of the class before it. Then we find the midpoint. We find the midpoint. That's 59 and 60. The midpoint is 59 plus 60 divided by 2, and that will give you 59.5. So the 59.5 is the lower class boundary of the median class. 59.5 is the lower class boundary of the median class. Then the summation of the frequency, we have already gotten that one while we are calculating the mean. So that's giving us 50 divided by 2, which gives 25. So summation of f divided by 2 is 25. Then we now go for cumulative frequency of the class before the median class. So how do we get the cumulative frequency? So that's 6 plus 8. 6 plus 8 gives 14. That gives the cumulative frequency of the class before the median class. So this is the class before the median class. Its cumulative frequency is to add the frequencies, all the frequencies before the median class, which is 6 plus 8 giving us 14. That's 14. Then we now have the frequency of the median class. The frequency of the median class is 12. So we have 12. And the class size. To get the class size, C means the class size or the class width. The class size or the class width. To get the class size, we find the difference between the upper class boundary and the lower class boundary of the median class. So to get the upper class boundary, we look at the upper limit and the lower limit of the class after the median class. So the midpoint there again is 69.5, then minus the lower class boundary. We've gotten the lower class boundary of the median class to be 59.5 minus 59.5. We have it as 10. We now substitute all these parameters in the formula. So we now have 59.5 plus 25 minus 14 divided by 12, then times 10. So we have substituted these parameters in the formula. So we have 59.5, 25 minus 14 gives 11. So 11 times 10 gives 110 divided by 12. So from our calculator, we have the final answer to be 68.67, which represents the median weight of the members in the sport club. So now we go to the mode. So the formula for the mode, we have LM delta 1 over delta 1 plus delta 2 multiplied by C. So we multiply by C. We need to also get the modal class here. To get the modal class, we go to the class with the highest frequency. This is the class with the highest frequency here. Since this class has the highest frequency, that is the modal class here. So the modal class, we look for LM. LM is the lower class boundary of the modal class. To get that again, we consider the lower limit of the modal class and the upper limit of the class before it. Since it is arranged in ascending order, it's before it. So we have 69 plus 70 divided by 2. It gives 69.5. Then we have delta. Delta 1 is the difference between the frequency of the modal class and the class before it. That's going to give us 14 minus 12, which gives 2. And delta 2 is the difference between the frequency of the modal class and the class after it. So that's going to give us 14 minus 7, which gives 7. And again, our class size, so is the lower class boundary, and the upper class boundary, we are going to find the positive difference. So the upper class boundary here is 79.5 minus 69.5, which gives 10. And we now substitute this into the formula for mode. So LM is 69.5 into 2 over 2 plus 7, then multiply by 10. So here we have a 69.5 plus 20 over 2 plus 7 gives 9. 20 over 9. From our calculator, we have it as 71.72 as the modal class of this distribution. That brings the end of the solution to this problem on how to solve mean, median, and mode of grouped data. Please remember to subscribe to our channel at Oninab Resources, and thank you for watching this video. Bye.